Lower-level designers, LLD, focus on translating high-level system designs into detailed component-level designs, including class diagrams, database schemas, API specifications, and internal logic flows. They ensure each module's structure and behavior is clearly defined for developers to implement efficiently. In today's video, we explore 19 LLD interview questions and answers. Each answer can be customized to highlight your unique qualifications and experiences. Before your interview, be sure to research the company and review the job description so you can include key skills relevant to the job role in your answers. Question number 1. What is the purpose of low-level system design in software development? Hiring managers ask this to see if you understand how LLD fits into the overall software development lifecycle. They want to know if you can translate high-level requirements into actionable components and structures. It's also a test of how well you understand system scalability, maintainability, and collaboration with engineering teams. The purpose of low-level design is to take the high-level architectural plan and break it down into actual components like classes, methods, interfaces, and database schemas that developers can use to build the system. It's where we get into the nitty-gritty details, how data flows, how services interact, and how responsibilities are divided. Good LLD helps prevent confusion later in the development cycle because it sets clear expectations for functionality, boundaries, and data models. It also makes the system easier to scale and maintain since you're thinking through dependencies, error handling, and modularity early on. In my experience, LLD serves as the bridge between the big picture vision and the hands-on coding. If it's done well, it can reduce bugs, make onboarding smoother, and speed up development cycles. I think of it as setting the foundation for clean, understandable, and testable code. Question number 2. How does database indexing optimize query performance? This question checks your understanding of performance tuning and system responsiveness, key concerns in backend and LLD roles. Indexing is often overlooked in early design stages, so they want to know if you're thinking ahead about real-world usage. It also tests your ability to balance performance with trade-offs. Database indexing speeds up query performance by reducing the number of rows the database has to scan. It works like an index in a book. You don't read every page to find what you need, you go directly to the right section. For example, if you're frequently querying a user table by email, creating an index on the email column will make those lookups much faster. I've used B-tree and hash indexes depending on the access pattern. The key is knowing your most common queries and designing indexes that support them. That said, I'm careful not to over-index. Indexes take up storage and can slow down write operations like inserts and updates. So during LLD, I usually collaborate with DBAS or backend engineers to figure out what data access patterns we expect, and we design indexes around that. A few well-placed indexes can make a system feel way more responsive without adding much complexity. Question number 3. What are the essential considerations in designing a schema for a relational database? This question tests how well you understand data modeling and long-term maintainability. Schema design directly affects performance, scalability, and integrity. Hiring managers want to see if you're thinking beyond the immediate requirements and planning for real-world use cases and future growth. When I design a relational database schema, I start by understanding the core entities and how they relate. Customers, orders, products, things like that. I think carefully about normalization to avoid data duplication, but I also consider where denormalization might help with performance. Data integrity is key, so I use constraints like foreign keys and unique indexes to make sure we don't end up with inconsistent records. I also pay attention to naming conventions and data types so that the schema is readable and easy to maintain. Another thing I always factor in is how the data will be queried. If a table is going to be accessed a lot for reporting or filtering, I'll consider indexing or even partitioning strategies during design. So for me, schema design is about balance, structuring the data in a way that's flexible, efficient, and clean without locking yourself into a corner when things evolve. Question number 4. Why is concurrency control important in multi-threaded systems? Concurrency control is critical in systems that need to scale and handle real-time data. Hiring managers want to see if you understand race conditions, deadlocks, and the risk of data corruption. It also shows whether you're capable of designing thread-safe components that won't break under pressure. Concurrency control makes sure that when multiple threads or processes try to access shared resources, they don't interfere with each other or corrupt the system state. Without it, you might get two threads updating the same user balance at the same time, leading to unexpected results. I've used locking mechanisms like mutexes and semaphores, and I've worked with transactional systems where you rely on isolation levels and atomic operations. But I try not to overuse locks because they can hurt performance or lead to deadlocks if not handled carefully. When I design low-level systems, I try to think ahead. What parts of the code will run in parallel and what needs protection? I often use patterns like thread-safe queues or actor models when appropriate. Getting concurrency control right is about protecting integrity while still keeping things efficient and responsive. Question number 5. What are UML behavioral diagrams? This question checks your understanding of system behavior representation using UML. Hiring managers want to ensure you can clearly model how components interact and how the system reacts over time. It helps them evaluate your communication skills and whether you can bridge the gap between abstract ideas and concrete behavior. UML behavioral diagrams are used to represent how a system behaves over time in response to internal or external events. They include diagrams like use case, sequence, activity, and state diagrams. Each one focuses on a different aspect, like user interaction, flow of control, or state changes in an object. I typically use sequence diagrams to show how objects communicate in a time-ordered fashion and state diagrams to explain transitions based on specific events. For example, in a payment processing module, a state diagram might track the transaction through initiated, processing, approved, or failed states. These diagrams help clarify how components should respond and interact, especially when discussing system behavior with both developers and product teams. They're great for uncovering edge cases early in the design phase and making sure logic is well understood before implementation. Question number 6. How do you model a sequence diagram for a user login process in UML? This tests your ability to translate a common user flow into a detailed, structured design. Hiring managers want to see how you approach typical system interactions and whether you can clearly capture responsibilities across different components. It's also a way to evaluate how comfortable you are with visualizing real-time operations. For a user login process, I'd start by identifying the main participants: the user, the UI, the authentication controller, and the user database. In the sequence diagram, the user initiates a login request through the UI. The UI sends the credentials to the authentication controller, which then queries the user database to verify the username and password. If the credentials match, the controller sends a success message back to the UI, and the user is granted access. If not, it returns a failure message with the appropriate error. I'd also show any optional steps, like rate limiting or CAPTCHA, depending on the system's complexity. The key in sequence diagrams is to show the order of operations and which components are responsible for each step. I include return messages and alt blocks for success and failure scenarios so the flow is easy to follow and covers more than just the ideal case. Question number 7. How would you model the behavior of a system using a state diagram in UML? This question checks whether you can represent dynamic behavior and transitions. Hiring managers want to see how you model internal state changes triggered by events, especially important in systems with lifecycle management or condition-based flows. It reflects how well you understand state-driven logic. I use state diagrams when I want to describe how an object or system changes states in response to events. Let's say we're designing an online order system. The order could start in a created state, then move to confirmed, then shipped, and eventually to delivered or canceled. Each state change would be triggered by a specific event like payment confirmed or user canceled. I also model conditions, like transitions only happening if stock is available. Actions can be attached to transitions. For example, when moving to shipped, the system might trigger an email notification. State diagrams are really useful when the system has strict state flows or rules, like user sessions, transactions, or workflows. They help catch logical flaws early, like impossible transitions or missing exit conditions, before code is written. Question number 8. What factors influence the choice of appropriate data structures in low-level system design? Hiring managers ask this to assess your ability to make trade-offs in performance, memory, and use cases. Data structures are foundational to low-level design, and your choice can dramatically affect scalability, speed, and maintainability. They're looking for depth of understanding, not just what structures are, but when to use them. When I choose data structures, I think about the operation patterns first. Are we doing lots of lookups, inserts, deletes, or something else? If I need fast key-based access, I might choose a hash map. If I care about order, maybe a tree or a linked list. Memory usage is another factor. A trie, for example, is great for prefix lookups but can consume a lot of space. If I'm working in a memory-constrained environment, I have to balance speed with efficiency. I also think about concurrency. If the structure will be accessed by multiple threads, I need to consider thread-safe implementations or design around that. The key is knowing what the system needs most: speed, space, order, or thread safety, and then picking the structure that best meets that need. I try to keep the design simple unless performance really requires a more complex approach. Before we continue, I just want to take a moment to thank you for watching this video. You can download a copy of these interview questions and answers in PDF format by clicking on the link below and supporting my channel by making a minimum donation of $3. Your support allows me to keep creating valuable content to help you pass your interview and land your dream job. Thanks for your support and appreciation. Question number 9. When designing a database schema, what are the benefits of normalization? They want to know if you can design clean, efficient databases that avoid redundancy and promote data integrity. Normalization is key to building scalable systems, so this helps them gauge your understanding of relational database principles and long-term maintenance strategies. Normalization is all about organizing data to reduce redundancy and improve consistency. When I normalize a database, I aim to make sure each piece of data lives in one place. So if I need to update it, I don't have to chase it down in multiple tables. That cuts down on errors and keeps everything cleaner. It also makes the structure more flexible. For example, if I normalize customer information into a separate table, I can link that customer to multiple orders without repeating all their details. This makes queries more efficient and the schema easier to maintain. I usually normalize up to the third normal form unless there's a strong performance reason not to. There are times when denormalization makes sense, like for read-heavy systems. But I always start normalized and adjust based on actual use cases. It's a good default approach for clarity and integrity. Question number 10. How do you design an efficient logging and monitoring system for a complex application? This question checks if you think beyond just writing code. Hiring managers want to know that you're thinking about observability, real-world performance, and troubleshooting. A good answer shows you care about how systems behave in production and how teams can stay informed without being overwhelmed. I start by defining what needs to be logged: errors, warnings, and key system events like user logins or failed transactions. I use structured logging so logs can be easily parsed and analyzed. JSON format works well for this, especially when paired with log aggregation tools like ELK or Datadog. For performance, I avoid logging inside tight loops or high-frequency code paths. I make sure the logging level is configurable so we can turn on debug mode only when needed. Monitoring goes beyond logs. I include real-time metrics like request latency, error rates, and memory usage. These get pushed to a dashboard where alerts are triggered based on thresholds. I also set up health checks and uptime monitoring for each major component. The goal is to get useful insights without creating noise. A well-designed logging and monitoring setup helps the team respond to issues quickly, spot trends, and feel more confident when deploying changes. Question number 11. What are design patterns? Explain their importance in software development. Hiring managers ask this to check if you understand common solutions to recurring design problems. They're looking to see if you can write code that's not only functional, but also maintainable, scalable, and readable. This also shows whether you can speak a common language with other developers and apply best practices consistently in a system-level context. Design patterns are standard solutions to common problems that developers face in software design. They're not code you copy and paste, they're more like templates or guidelines for structuring your code in a clean, reusable way. Whether it's managing object creation, controlling access, or handling dynamic behavior, there's often a pattern that helps reduce complexity. They're important because they save time, prevent common pitfalls, and make code easier for other developers to understand and extend. In large-scale systems, especially, using well-known patterns improves consistency across teams. For example, when working on a notification service, we used the observer pattern so different parts of the system could react to events without tightly coupling components. It made future features much easier to plug in. Knowing when and why to use a pattern is what makes it valuable, not just knowing the definition. Question number 12. Can you explain the singleton design pattern and its use cases? Interviewers use this question to see if you understand how to manage shared resources in a controlled way. Singleton is one of the most well-known patterns, but it's also one that gets misused. They want to see if you know when it's appropriate, how to implement it safely, and how it fits into a larger design. The singleton pattern ensures that a class has only one instance and provides a global point of access to it. It's useful when you need a single source of truth for something, like a configuration manager, logging service, or connection pool. You don't want multiple instances competing or causing inconsistent state. In Java, for example, you might implement a singleton with a private constructor and a static method that returns the instance. In multi-threaded environments, you have to be careful with synchronization to avoid creating multiple instances by accident. I've used singleton for a centralized cache manager in a backend service. The cache needed to be shared across components, and singleton made sure updates were consistent no matter where they came from. That said, I'm careful with singletons. They can make testing harder and introduce hidden dependencies if not used thoughtfully. Question number 13. What is the observer design pattern? How would you implement it in a real-world scenario? This question tests your understanding of dynamic relationships between components, especially in systems where one change triggers actions elsewhere. Hiring managers want to know if you can decouple components while keeping them responsive. It's also a good measure of your ability to think in terms of events and subscriptions rather than tight coupling. The observer pattern lets one object, the subject, notify other objects, the observers, when its state changes. It's useful when you want to keep things loosely connected but still responsive. The classic example is a UI element updating automatically when the data changes, but it's just as useful in backend systems. In a real-world scenario, I used it to build a stock alert system. We had a central inventory manager, the subject, and when stock levels dropped, it notified a set of services like email alerts, restocking logic, and reporting dashboards. Each observer subscribed to changes but didn't know anything about the others. It kept the code modular and allowed us to add new features, like SMS alerts, without touching the core logic. I usually implement this with a simple list of observers, a subscribe method, and a notify function that calls each one. It's a clean way to manage cascading events without hardwiring everything together. Question number 14. Describe the factory design pattern and when you would use it. This question helps them evaluate how you manage object creation, especially when dealing with subclasses or different configurations. It's about encapsulating decisions and making code more flexible. Hiring managers want to see if you can abstract logic so your code doesn't break when new types are added or requirements change. The factory pattern is used to create objects without specifying the exact class that will be instantiated. It's helpful when the exact type of object isn't known until runtime, or when creating different objects requires complex logic. Instead of using new directly all over the code, you delegate that job to a factory method or class. I use the factory pattern in a payment processing system where different payment methods like credit card, PayPal, and bank transfer needed different initialization. Instead of putting all the logic in one big block, we created a payment factory that returned the right object based on the payment type. That way, adding new payment types didn't require changes to the core workflow, just a new class and an update to the factory. It made the system easier to maintain, test, and extend. Factory is especially useful when object creation is more than just simple instantiation. Question number 15. What is the strategy design pattern? Hiring managers ask this to see if you understand key object-oriented design principles and can apply them to real-world problems. They're interested in your ability to write flexible, maintainable code by choosing the right patterns. A solid grasp of the strategy pattern shows that you can decouple logic and behavior for systems that may need to change or scale. The strategy design pattern is about defining a family of algorithms or behaviors and making them interchangeable without altering the context that uses them. It helps when you want to change part of an object's behavior at runtime without rewriting its core logic. I've used it when designing a payment system that needed to support different methods like credit cards, PayPal, and wallet balances. Each payment method had its own processing logic, so I created a common interface and had each method implemented separately. The main service just called the interface, which made it easier to extend in the future. It keeps things clean, testable, and more modular. If a new method comes in, I just plug it in without touching the existing code base. It's especially helpful in LLD when you want to keep your classes focused and changes localized. Question number 16. How would you design a logging mechanism for troubleshooting and performance analysis in a distributed system? Logging is critical in distributed systems where failures are harder to trace. Interviewers want to see if you can design something that scales, preserves context, and doesn't introduce performance bottlenecks. They're looking for structured thinking around observability, fault tolerance, and log aggregation. I'd start by defining a centralized asynchronous logging mechanism using something like FluentD or Logstash to collect logs from different services. Each service would push structured logs, ideally in JSON format, to a local buffer that forwards entries to the central system. I'd include key metadata like timestamps, trace IDs, request IDs, and service names to support distributed tracing. For performance, I'd make sure the logging runs on a separate thread or uses non-blocking queues so it doesn't affect the main application flow. To troubleshoot issues, I'd integrate logs with a visualization tool like Kibana or Grafana and set up alerts for anomalies. We'd also separate logs by type, info, warn, error, debug to filter them based on use case. For long-term performance analysis, I'd archive older logs to cold storage like Amazon S3. This setup makes it easy to debug incidents, analyze trends, and stay ahead of system bottlenecks without overwhelming the services themselves. Question number 17. Describe the factors influencing the choice of appropriate algorithms in the design of a sorting system for large datasets. Hiring managers want to know that you can balance theoretical knowledge with real-world trade-offs. Sorting large datasets can be expensive, so they're looking for your ability to think through time and space, complexity, memory usage, stability, and parallelization. Your answer shows how well you adapt solutions to scale. When choosing a sorting algorithm for large datasets, I look at data volume, distribution, available memory, and whether the sort needs to be stable. For in-memory operations, quicksort is often fast, but for massive datasets, I'd lean toward external sorting methods like merge sort variants, which can handle disk-based input. If I know the data has constraints, like mostly sorted or limited range, I might use something like insertion sort or counting sort to optimize performance. I also consider whether we can sort in parallel across partitions using tools like MapReduce or Spark. Another big factor is stability. If the original order needs to be preserved for similar keys, some algorithms are better than others. It's also important to account for network and I/O overhead if the data is coming from multiple sources. It's not just about choosing the fastest algorithm, it's about picking one that works best given the structure and constraints of the dataset and the system it runs on. Question number 18. In low-level system design, How do you handle versioning and backward compatibility in evolving software systems? Systems evolve, and backward compatibility is a must in production environments. This question tests your understanding of long-term software maintenance, API evolution, and user impact. Hiring managers want to see if you can think ahead and design systems that age gracefully. I handle versioning by designing APIs with version identifiers in the URL or headers, something like /API v1/ so new changes don't break existing clients. For backward compatibility, I avoid removing fields or changing behavior in place. Instead, I deprecate features gradually and monitor usage before phasing them out. On the back end, I keep multiple versions of services or data transformation logic if needed, so different consumers can continue working. If the system involves shared schemas, like with Protobuf or Avro, I follow rules for backward-forward compatibility, like not renaming fields or changing data types. Communication is key too. I make sure to document changes and notify stakeholders in advance with proper timelines. By planning ahead and giving clients time to adapt, we avoid breaking things in production. The goal is to evolve quickly without making it painful for others to keep up. Good versioning practices help systems stay flexible and easier to manage over time. And finally, here's the last question. Question number 19. How would you design a secure authentication and authorization system in a distributed application? Security is a critical part of any system design. This question tests your ability to think through identity management, token handling, and protecting sensitive data. Hiring managers want to see that you understand both the technical and architectural layers of building secure systems. I'd start with authentication using a token-based system, most likely OAuth 2 with JWTs for stateless access. The login service would verify credentials, issue a signed token with user roles and permissions, and clients would attach this token to subsequent requests. Each microservice would validate the token using a shared public key or secret before processing the request. For authorization, I'd use role-based or attribute-based access control depending on complexity. Sensitive operations would require checking scopes or specific claims in the token. To avoid hard-coding permissions, I'd store policies in a central service and cache them locally with expiry. Since this is a distributed system, I'd make sure tokens have a short lifespan and use refresh tokens when needed. Communication between services would be encrypted with TLS, and I'd log access events for auditing. Designing this way keeps authentication centralized, tokens lightweight, and authorization flexible. It's secure, scalable, and allows services to verify trust without repeated database calls. If you want to learn more on how to land jobs and reach your career goals, don't forget to hit that subscribe and bell notification button to get new videos every single week. Also, don't forget to hit that like button because that motivates me to keep doing what I do. Stay safe, keep smiling, and good luck.